In the seventh part of ledge climbing I will be making a drop to ledge system. This will allow the player to drop down and hang onto a ledge if they are close enough to it. The player will find the closest ledge to them and then drop down. The animation is not that good, but you can replace it for a more suitable one if you have. First I will get the animation. Go to Mixamo and I will be using drop to free hang. Before you download it, find the point in the animation where the player finishes dropping and hangs. Make note of the current frame in the bottom. Then download it without skin. Then go to this Mixamo to Unreal Converter. Press Custom Root Motion. Set the frame, height, and rotation to 0. Then press the Add button. Set the frame to the one we just found, set height to 0 and rotation to 180. This is done since the animation is not rotated correctly to match our ledge climbing functionality. Now open Unreal Engine. I will make a new folder for the drop to hang animation. Import the animation. As you can see, the root bone is rotating until the end of the frame we set. The root bone also has Z movement, which is since we set the height to 0. Open the player blueprint. I will use the F key for dropping. Make a new function called drop from ledge. Add a for loop with break. For the last index, make a literal int and set it to 8. We will be using this to trace around the player in a circle. Add a capsule trace by channel. Get the actor forward vector and rotate vector. Split the pin and multiply the index by a float, then connect it to yaw. Convert the literal int to a float and divide it from 360. This will be the value to multiply by. The maths here is that we need to trace around in a circle which has 360 degrees, so we divide 360 by the total amount of traces we are doing to find the increment, then multiplying that increment by the index to find all 8 values equally between 0 and 360. Now get the actor location and add vector. Multiply the rotate vector by a float. Set it to 150. Press add pin and set the Z to -150. This is the start and end for the trace. The radius and half height will be that of the capsule components. I will make the draw debug type an input for easier testing. Add a branch out of return value. If this is false, then player can hang there. Add a sequence. Connect then 0 to break from the for loop. Now make a new local integer variable called index. In then 1, set its value to the for loop's index. For then 1, call the trace ledge function. You can copy these values for the inputs. Then add a return node and set the outputs to the outputs of the trace ledge function. Add the return node in completed of the for loop 2, leaving ledge detected as false. This is since the for loop will break if a hangable location is found. So if it completes, it means a location was not found where the player can hang, and so the output should be false. Open the trace ledge function as we need to slightly modify this. Add 2 new vector inputs called initial location and trace direction. Delete get actor location here and replace it with initial location. Replace this get actor forward vector with the trace direction input. Now right-click the function and find references. This is since we used this function before and need to connect the inputs. For the ones we have used previously, initial location will be get actor location and trace direction will be get actor forward vector. Now go back to drop from ledge function. For the initial location, set the capsule traces location. For the trace direction, get the actor forward vector. Rotate vector and yaw will be the index multiplied by the 360 divide by. This is done as we need to trace between the target location and the player, which will be based on the circular line trace we did. Multiply it by -1 for the trace direction. I will now comment the function. Go back to the event graph. Add the function and connect it to the key pressed. As you can see, when I press F, a trace happens in a circle, and once a trace returns false, the trace ledge function is called from there towards the ledge. However, there is an error where it is not hitting the ledge. Open the drop from ledge function and modify the code for the start-end location of the capsule trace as shown. Now the traces are hitting the ledge. Now go to the drop animation. Enable root motion on it. Now create an animation montage of it. Add a motion warping notify. It should start when the player starts to drop down. It should end when the player finishes dropping, but before the frame we marked in the beginning. Set the end time to 1.55. Set the name of the warp target to hang position and uncheck ignore Z-axis. Go back to the player blueprint. Make a new macro called drop from ledge component. Add a branch node and connect condition as an input called canDrop. Add two vector inputs called ledge location and ledge normal. Add a move component to node for the capsule component. Add a vector to ledge location. Its value will be ledge normal multiplied by -50. Split the pin and add the get actor location node. Make a vector with these inputs. Open the hang on ledge macro and copy this part. Paste it in drop from ledge macro. Connect these pins as shown. On completed, add a sequence. Then 0 will be set movement mode to flying. Then 1 will be add or update warp target. Make a motion warping target for it. Set the name to hang position. The location and rotation of it will be the values from the code we just copied. Next get the mesh and play montage. The montage will be the drop to hang montage. On blend out, set is on ledge to true and hand IK target alpha to 1. Then call the hang on ledge macro. For ledge location add a subtract node. The z of the value to subtract is 10. Then connect ledge location to it. Also connect the ledge normal input to the macro. It is recommended to rearrange these nodes and add reroutes to make it more readable. Go to the event graph. Add the drop from ledge component macro. The inputs of it are the outputs of the function. There is an error with the location of the animation. Go to the drop from ledge macro. Change this value to 90. Press add pin and set Z to 80. The system is now working properly. The animation is a bit bumpy, so it is recommended to replace it with a better one if you have. That is all for this video. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.